Welcome back, guys. So today we are solving the GFG problem of the day. Print leaf nodes from pre-order traversal of a binary search tree. It is rated medium. And before moving on to the question, please subscribe to our channel. We solve GFG problem of the days and lead code daily challenges and all the contest solutions of Code Chef, Code Forces, and lead code you will get here. Okay. So the question states that we are given a pre-order traversal of a binary search tree. We have to find the leaf nodes of the tree without building the tree. If you had to build the tree, I guess you could have done it. Okay. We can first we are given the pre-order traversal, so we could have sorted it, and we could have got our in order traversal, and by comparing the in order and the pre-order traversal, we could have made the binary search tree, and we could have used any traversal through the binary search tree and print the nodes, which are the leaf nodes. Okay. Which are the leaf nodes? The nodes which points the node whose left and right both point to null. Okay. So that was the naive approach. Okay. But the better solution will be, you can go to GFG and see a big O n log n solution. But today I'm teaching you the big O n solution. Okay, using stack. That is the most optimal one. Okay. So like here we are given uh, two nodes, two and one. The leaf node is one, so we print our output one. Similarly here we have 3 to 4 our array, and 2 and 4 are the leaf nodes, so we print the leaf nodes only. Okay, print or we return the factor. Okay, so let's see how we can do this. Okay, here I have the solution. Yeah, so here I took the example from the GFG article. I guess this is the best example I could find. Okay, so if this was the case, if our pre-order was given 150 20 65 and 150 20, or this is the case 1 and this is the case 2. If it was given 150 20 65, okay, so this is our binary search tree. But in case 2 we have 150 20 40, and this is our binary search tree. You can see that here 20 and 65 both are leaf nodes, and here only 40, but the pattern is same. First we have a decreasing order, like 150 20, and then 65 is the one that is increasing, and similarly here we have 150 20 and 40 is the one increasing. So how can we determine that here 20 and 65 both are leaf nodes and here only 40 is the leaf node? So the algo is pretty simple. What we do is we traverse the pre-order array given to us, and we set two pointers, I is equals to 0 and j is equals to 1. Like here, I is pointing to 100 and j is pointing to 50. Okay, every case where a of I is greater than a of j, that means we are going left of the binary search tree. That means in a binary search tree every left element is smaller than the node element. Okay, so we are going left, then that means we will get a decreasing order. So 10 50 and 20, here we get a decreasing order, so we push into the stack. Okay, 10 100 goes into 50 goes into, and when we come to this, I equals to 20. Okay, I equals to 20 and j is equals to 65. Here the here it defies the condition. So what it does is, the a of I, that is 20, is not greater than a of j, that is 65. So what we do is we go to the else part. So what we do here is we empty the stack. Until the stack is empty, we traverse this and see, and have a found flag that will mark true if we get any leaf node. Okay, so like here, if you can see, a of j now is 65 and the top of the stack is 50. Is 65 greater than 50? Yes, it is. So we pop and we mark the found as true. So if the found is true, then we push back a of I. Okay, and if the found is true, then we push back a of I. Okay, here we break out of the loop when, then we pop 50, then 65 is greater than 100, that is false, then we break. Okay, then we see that if found double equals to true. If found double equals true means we found a leaf node, and which is the leaf node? That is a of I. that is 20. Okay, and then we push the rightmost element in after the whole loop is executed, means the whole zero one has executed n times. Okay, so after this whole is executed, we push the rightmost element into the answer, because because the rightmost element is always a leaf node. If you can see, the rightmost element is always a leaf node. The if it the tree was built fully, then the rightmost one, the extreme right, will always be a leaf node. So we at last push that extreme right one into the answer vector. Okay, so like here, the array n minus 1, that is 65, is pushed into the answer vector. So we finally get 20 and 65 as our answer. So come to case 2. In case 2, we can see that we are going on left, 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 and it is going on in a decreasing order. And finally, when we have I and j, where j is greater than I, that means it defies this condition, I is less than j. So here we push only if a of I is greater than a of j. That means we are going on decreasing, so we push it into the stack. Okay, so here it defies the condition, so we what we do is we execute the else part. Here in the else part, what we have in the top, 50, and what is a of j, 40. From first, it is not satisfying the condition, so our found is false. Okay, it doesn't get converted to true. We break out, and when we break out, we see if our found double equals true, that is not, it is false, so we don't push back anything. So after every traversal, we at last push back only the last element, that is the rightmost leaf node, that is 40. So our answer is only 40. Okay, so here, this is the code. So this is the code. Here, as I told, that I traversed the I and j are, up to n, and then what we do is we set a found flag to false. And in decreasing order, we if the we go on filling the stack in a decreasing order. Decreasing order in the sense is that all the left nodes, okay, we push it in the stack. Else what we do is the algo part. Okay, we pop only if the a of j is greater than the stack. Okay, and at last, if the found is true, then only what we do is, if the found is converted to true, then only we push the preorder of I to the answer vector. Okay, so finally, at last, what we do is we push the rightmost element, and then we return this. We don't return, I have basically taken a void, and I have passed the address of the vector. So the address of the vector is changed, and the vector is returned in the leaf nodes function. Okay, so we get our answer as the correct answer. So we let's submit it and see. Yeah, it's good to go. Thank you.